Last year at the UX 360 conference, I did a talk on the future of quant research. The talk focused on how quant research had evolved and changed with the introduction of new tools like Qualtrics and SurveyMonkey that made it easier to design surveys and conduct statistical analysis. This was obviously before ChatGPT was introduced in the market and became an overnight hit. I would have given a very different talk if ChatGPT had been in the market at that time. Today, I want to share how you can use ChatGPT for simple statistical analysis. So, here we go. To be able to do statistical analysis, you need to upgrade from ChatGPT 3 to ChatGPT 4, and the subscription cost is $20 a month. And advanced data analysis is still in beta, so you'll have to go to your settings here and go to beta features and enable advanced data analysis, which, as you can see already over here, that I've already done it. Since I didn't have a data set readily available, I decided to begin with analysis on COVID-19 data. That turned out to be quite an adventure. I looked for data sets on Kaggle and downloaded some and ran descriptive analysis on the data, only to find most of the data sets were not usable because many of them had too many missing values. I also found data on COVID-19 from National Institute of Health site. After spending an hour or two working on that data set, I found that data also had issues. It showed perfect collinearity between certain health conditions like obesity and diabetes and being a senior. ChatGPT was unable to explain why the data showed perfect collinearity. Since I was not familiar with the data and short on time, I decided to pivot and use a data set that I was more familiar with. This was my big learning, that you need a human, a researcher, who is familiar with the data set to be able to troubleshoot. You can't rely on ChatGPT alone to do QA on your data. So I'm using data from the survey that I had conducted of Wikipedia editors in 2011 when I worked at Wikipedia. I'm mildly familiar with this data. It's been 12 years since I wrote the survey and conducted in-depth analysis on the data. This data set contains data on Wikipedia editors and their editing habits. It also has demographic data for editors. Since I'm familiar with this data set, I'll skip learning about the variables in the data set. Otherwise, if you're unfamiliar with the data set, you should ask ChatGPT to tell you what are the columns or variables or rows or individual responses in the data. I also had to recode several variables since ChatGPT did not know how the data was coded at the back end. So let me jump straight into analysis. I've already uploaded the CSV file here, and ChatGPT only likes CSV files. I tried to use numbers file. I tried to use SPSS file. It was unable to work on those. So the first thing I want to look at is the editing history of editors. I want to know the distribution of the number of edits. So let me ask ChatGPT, what is the minimum, maximum, average, and median for number of edits? Let's see what it comes back. So it is loading the data from the CSV file. And what's really cool is that it does tell you that you can see the work, so you can look at the Python code that it has used to generate the answer. And as over here, as you can see, the minimum number of edits is 0, max is 560,000, the median is 8,325, and the average is 8,325, and the median is 1,300. The next thing I want to know is that what percentage of editors edit English Wikipedia? Because I know by working at Wikipedia is that obviously English Wikipedia is the largest. So let me ask ChatGPT, what percentage of editors edit English Wikipedia. Typo. That's interesting. It is looking at the start language column. It's assuming that the language in which the respondents took the survey, which is English, is the primary language for editing Wikipedia. This response is actually incorrect. I created a dummy variable in this data set called English that captures whether someone edits Wikipedia. So let me ask that question. What percent of responses have value of 1 in English variable? Let's see what's the answer this time. Okay, looks like it has, it was, this time it's given me the right answer, that about 71% of those who we surveyed edit English Wikipedia. So the first answer was wrong, the second answer is right, and the only reason why I was able to figure out that the first answer was wrong is because I am familiar with this data set. Now, let me run a very simple regression analysis. I want to understand whether age and education has an effect on editing history. So conduct a regression analysis with editing history as a dependent variable. Typo. And age and education as independent variables. All right, let's see what comes back. Oh, it's giving me 2 responses. Interesting. Okay, so it's we need to check and handle any missing values. So education is a categorical variable, so it has recommended to turn it into a dummy variable. So it's handled missing values for number of edits, age, and education. Great. And it's converted the categorical variable education into dummy variable. And it's conducting ordinary least square regression. Okay. Independent variable, number of edits, independent variable, age and education. Key finding. The R-square value obviously is pretty small. This model is very simplistic, and it's only able to account for 1.3% of the variability. The coefficient for age is positive, and it is significant, which shows that older editors are more likely to edit Wikipedia. For education, it created a dummy variable. So let me see what the reference variable here is here. I have the data here in the code book. So the reference variable is primary education, and it's comparing secondary education to primary education. And what it's telling me here is that it is significant, as well as people who have tertiary or undergraduate education, they are more likely to edit than those who have primary education. Those who have a master's degree are more likely to edit compared to those who have a primary education. Those who have a graduate degree are more likely to edit compared to those who have a primary education. I think it did some great work. It's clearly great for doing analysis. I didn't create any visualizations, but When I was playing around with it, I did use it to create some bar charts, and it did a pretty great job of that. But based on all this work that I have been doing with ChatGPT, my big learnings are ChatGPT can do analysis for you, but as a researcher, you have to be familiar with the data set. You need to know, does it have missing values? How is the data set coded? You have to have a hypothesis to be able to do the analysis. ChatGPT can show your regression equation has a poor fit, but it can tell you why. So, as researchers, we want to ensure that we're creating a model that's based on theory or hypothesis based on what we have observed. So, like here, obviously the model it's a pretty poor fit. Um, but it's not telling me that there's a specification error, that there are variables that are important that I have not included in the analysis, and I know that's true. uh, I did not include gender as a variable, as an independent variable in this equation, and I know from my previous work and data that 90% of Wikipedia editors are men, and women editors stop editing Wikipedia because of online harassment. I did not add it as a predictor variable in the regression equation, and I would have expected ChatGPT to tell me that there was a specification error, that I had left out some important variables, but I did not see that. In the end, I would say ChatGPT is a great tool, but it's not yet a substitute of the knowledge that researchers have in a particular subject area. So, my advice is go and play with ChatGPT and see if you can use it for your data analysis.